You're about to see a very short clip from America's Funniest Home Videos. This young lady she's got a hold of a rope swing, and she's jumping off a platform toward the river. Unfortunately, I don't think she listened to her physics teacher, or maybe she hasn't had physics class yet, but otherwise she would have known that at the bottom of the swing, when you're going the fastest, the centripetal acceleration is the greatest. And because the acceleration is the greatest, you have to come up with a greater amount of force. So at the bottom of the swing, you got to hold on more tightly than you did at the top of the swing. And unfortunately, as you're about to see, she didn't remember that fact. Let's watch. Every single minute. Well, I thought it'd be fun to kind of look at the physics of what was going on with that young lady in the video. So I've created a problem, hopefully fairly consistent with what we saw. I've given her a mass of 50 kilograms, which is about 110 pounds. And we couldn't tell, but I'm going to make the rope about 15 feet long, or 4.6 meters. From watching the video, I thought that ramp she was standing on was probably around 5 feet high. Didn't look to be about the same. Looked to be about the same size she is. And so, using some physics, which we'll get into in another unit later on, I took that height, and I came up with a speed of about 5.4 meters per second at the bottom of the swing. So the question would be, what would be the tension of the rope at that moment? And of course, because that's how hard she would have to be pulling with her hands in order to keep herself from falling. So, as you can see, I've already got a little drawing. So let's do a free body diagram of her. So if this is her, and here, of course, is the center of her swing circle, she would be experiencing a tension up and a weight down. And because the tension is towards the center, the tension is greater than the weight, and so the correct formula would be T minus the weight equals mv squared over r. So the tension would be equal to mv squared over r plus her weight. So right away we begin to understand why she falls, because she has to pull harder than her own weight. She has to pull with an additional force equal to whatever mv squared over r is. So now we can substitute some numbers, given her mass of 50 times 5.4 squared over the rope, which I'll say is 4.6, plus 50 times 9.8. So the tension would be equal to 317 newtons plus 490 newtons. So remember, the 490 is her own weight, so if she was just hanging there from the rope, she has to hold on with 490 newtons, but because of her swing, she has to come up with an additional 317 newtons. So putting that all together, 807 newtons. And that, by the way, if I take 807 and I divide it by 4.45 pounds per newton, that works out to be about 181 pounds. Now remember, she only weighs, with our situation, she only weighs 110 pounds. So, but at the very bottom of the swing, she had to hang on as if she weighed 181 pounds. And if you're not ready for that, if you don't know that's coming, it's pretty easy for your fingers to slip off the rope and as we saw, have a disaster on national TV.